If you're diving into Python, you've probably heard the term variables a lot. For some, the labeled box analogy works great, but what if you're someone who thinks a bit more mathematically? If you've ever dealt with algebra, you already have a fantastic foundation for understanding variables and programming. Today, we're going to explore Python variables by directly comparing them to the variables you've used in mathematics. We'll see how they hold values, participate in calculations, and even how they can change. So let's bridge the gap between math and code. In mathematics, especially in algebra, what is a variable? It's typically a letter like x or y that represents an unknown or changeable quantity. For example, if I write x equals 5, here x is a variable and we're saying its current value is 5. If I then write y equals x plus 3, you now know that y will be 5 plus 3, so y becomes 8. A variable in Python is essentially the exact same concept. It's a symbolic name that refers to a value. Just like x in math can hold the value 5 or later a different value like 10, a Python variable can hold numbers or even other kinds of data like text, and its value can change throughout your program. It's a placeholder for a piece of data. Let's translate that mathematical idea directly into Python. In math, we can say x equals 5. In Python, we can also say x equals 5. In math, we can say y equals 10.5. In Python, we can say y equals 10.5. In math, you can say something like let name represent Alice. In Python, variables can hold text too, so the equivalent would be name equals Alice. In math, you can access a number of prime. That can be true or false. In Python, we would represent that concept by naming a variable and giving it the value of true or false, like is prime equals true or is prime equals false. Just like in math, where you use the equal sign to assign a value to a variable, in Python, the equal symbol acts as what we call the assignment operator. It takes the value on the right and stores it under the name on the left. Here's some examples: x equals 5, y equals 10.5, name equals Alice, is prime equals true, and is prime equals false. For x equals 5, here x is our variable, and its value is the integer 5. For y equals 10.5, y holds the decimal, or in Python known as a floating point number, 10.5. For name equals Alice, this is where Python variables extend beyond just numbers. The variable name holds a sequence of characters of text. In Python, this is also known as a string. In this case, the string of text is Alice. Notice the quotes, which signify text. For the variable is prime, this variable holds a Boolean value, which means true or false. It represents a true state. So when you see something like variable name equals a value, think of it exactly like x equals 5. And variable name is a placeholder, and value is what it currently represents. In math, once you define variables, you use them in expressions and equations. For example, if x equals 5 and y equals 3, then z equals x plus y. Would result in z equals 8. Python works exactly the same way. This is incredibly flexible. Python also automatically determines the data type of the value you assign to a variable. You don't have to declare a variable as an integer variable or a string variable. This makes writing Python code very quick, but it means you need to keep track of what kind of data your variables are currently holding, especially as your program gets more complex. In math, you often have scenarios where a value changes over time or after an operation. Think about finding a running total or updating a counter. Python variables work the same way when you reassign them. When you reassign a variable, the old value is simply replaced by the new one. This ability to easily update values is crucial for building any interactive program. Just like in math, where you might choose meaningful letters for variables like T for time or D for distance, Python has rules and best practices for naming your variables. Good naming makes your code much clearer. Here are some rules. Rule 1. Variables must start with a letter or an underscore. Here's an example that won't work because it starts with a number. Here's an example that works. Rule number 2. Variables can contain letters, numbers, and underscores. Here's an example that doesn't work. The hyphen is not a number, letter, or an underscore, so that's why it doesn't work. Here's an example that works. Rule number 3. Variables are case sensitive. So my underscore var is different from capital M Y underscore capital V lowercase AR. Think of it like capital X and lowercase x, sometimes representing different things in specific mathematical contexts. Rule number 4. Variables cannot be Python keywords. These are words Python already uses for specific functions like if, for, print, true, false, etc. Here are some best practices. 1 is use snake case, which means all lowercase with words separated by commas. It looks like this. Avoid all lowercase letters in the variable, like this. It's hard to read. Best practice 2. Be descriptive. Your variable name should tell you what they represent. Just like area or circumference is more descriptive than A or C. Good examples are customer, page, and item count. Here's a bad example. Val 1. It's non-descriptive. Following these will make your code as clear as a well-written mathematical proof. Just like you can make a mistake in a math problem, you can make errors with variables in Python. Variables in Python are your programming equivalents of the x's and y's you use in algebra. There are symbolic names that hold values. You use a single equal sign to assign a value. Python variables are dynamically typed, meaning they can hold different types of data, like numbers and text, and can change their type. They can be reassigned and updated throughout your program, just like values in an iterative mathematical process. Good naming conventions make your code clear and understandable, just like clear notation in math. The best way to internalize this is to start writing your own simple Python programs. Experiment with different variable names, assign different types of values, and try using them in basic calculations. If you like this mathematical explanation of variables, please give this video a thumbs up, subscribe for more Python fundamentals, and hit the notification bell.